Okay, I think it's 1 o'clock Central Time. It's Tuesday. That means we have another episode of our HDF Clinic. Welcome everybody who is here today. And before I start anything else, I would like to ask if there are any questions about HDF5, your applications that use or may use HDF5. Any questions? Then we should start right there. Otherwise, I have a few things prepared and we can do something else first. Any questions? You should unmute yourself and feel free to jump in. Okay, that's not the case at the moment, so we'll just jump in. I don't have yet an answer about the file locking changes that were introduced in 1.12.1 and if we will bring them to 1.10.8. So I still owe you an answer to that. Let's look at last week's highlights. I think there's one pending announcement that we have, which is after our European Hug event earlier in the month, we have our Hug Americas event coming up in October, and you can still, until August 1st, submit a paper or presentation, and in this case, the abstract first, until August 1st, and then the event itself will happen online October 12th to the 15th. So stay tuned for that, and anything you think might be appropriate for that about your research, how it involves HDF5, or even if your research doesn't involve HDF5 and you have a reason or reasoning that you would like to share with us why HDF5 is not suitable, or you did not choose to use it, those things are fair game. This is a very open forum and we want to learn from each other why we make certain choices, and we want to hear the pros and cons. We know, I think we are the ones that definitely know that HDF5 is not perfect, and but we may even not know all the reasons why. Okay, there have been lots of interesting conversations happening on the forum. There was this one user that asked a question about migrating pandas files. So in pandas, there is an HDF5 store that you can use to store data frames in HDF5 files. And the user was asking if they were to use HSDS, if they could continue doing that. And John Reedy actually posted a nice comment also making reference to some articles that basically show how to do that. It's not as straightforward as with, since pandas does not use the H5Py module for its HDF5 store, it uses Pi tables, and the representation of data frames is a little different there. But people have found a variety of ways to get around that. And yeah, you can, and John is actually referencing one of the articles, how you can persist using H5Py, a pandas data frame, pretty easily. And then once you've done that, you can just say using H5PyD as H5Py, and everything should just work, and your application will be talking to HSDS at this point. So if this is a use case that applies to you, I recommend you go to the forum and read up on that thread, and it's hyperlinked here. So if you look at the notes later, there's a link here in case you don't know exactly where to go. Then there was another interesting discussion. There was a user commenting about the relatively, by comparison, poor performance of HSDS when working with local HDF5 files. And this sort of evolved into a very interesting sort of analysis. So the user seems to be very knowledgeable about sort of testing the performance of web interfaces and so forth. And he posted several tests that he conducted and trying to identify where exactly the slowdown comes from. And initially, it turns out, for example, that compression is very slow, and that can be eliminated, and then performance is slightly better. But still, at the moment, and it's also that the socket overhead that you might say, well, in a local machine, that's maybe a little artificial, but they were able to rule that out as a source of slowdown. And so where the discussion stands at the moment is that, the throughput with which the HSDS REST API transmits data is around 340 megabytes per second versus about almost 4 gigabytes per second with a sort of a vanilla REST service. And so right now they are investigating, well, what is that extra handling, that extra data preparation that HSDS is doing behind the scenes that eventually leads to this kind of a slowdown. But it is a very interesting thread to follow, and it once again shows that there is no shortage of talent and interest out there, and this is what is really good, is to have sort of the community independently examine these things and present their findings. Let's see. Next, there was a question today. Somebody was saying when you use the MPIO virtual file driver, so you do parallel HDF5 in this case, one of the arguments that you can provide is a communicator and also an MPI info object. And in that info object, you can specify certain things, MPI hints, but also if you want to do collective operations and things like that. And but the user was observing that when you set this to a file access property list, but if you later retrieve that file access property list and examine that MPI info object that you get from there, it turns out that the MPI info object actually does not contain all the hints and everything that is actually seen by MPI at a lower level. And so his question, I believe, is that why is that, or is that the expected behavior? And I don't know, I cannot give a definitive answer on that, but I think it is a feature, not a bug, in the sense that, I think the HDF5 library really only tracks MPI info hints as provided by the user when that file access property list was created. So if through the environment or other circumstances, you provide hints, for example, to an underlying parallel file system, be it Lustre, or I think those hints, when you then query with H5P get FAPL MPIO, you look at that MPIO object, these hints will not be automatically, so to speak, incorporated or discovered. And now it's debatable to say, well, should H5P get FAPL MPIO discover these things, yes or no? You can have a discussion about that. My gut feeling is no, because again, the FAPL that you recover this way should be identical in the sense of it should contain the exact properties and settings that were provided by the user, and not as a side effect of other things be different. originally provided. But it'll be interesting to see. I'm sure somebody from the HDF group will reply to that. But that's where that discussion stands. And then finally, this is just another ongoing thread in preparation for our HUG event in October. We have this open-ended thread out there where we would like to discover, sort of call them annoyances or things that, little things that you feel make your life with HDF5, working with HDF5, more difficult than necessary. And so if you have an idea, a suggestion, and so forth, find that thread and leave a comment, because we plan to then collect all of these suggestions and comments together in kind of a lightning talk format and then put it up for discussion. Okay, that's last week's highlight. I have something prepared for tips, tricks, and insights, but before I do that, I want to make sure we see if there are any questions. Any questions about what I said, questions that you had coming to this meeting, or speak up if you would like to make a comment or ask a question. Okay, that's not the case, then I'll just continue. So tips, tricks, and insights. Today, I chose something that actually came up during the European HUG event in one of the presentations. And it was this, if you look it up, presentation by Vijay Kardik, who works at DAISY. I put in the links to his presentation and his slides. But this is something that came up, and it's actually a very interesting HDF5 feature. It's maybe perhaps a little more advanced, but it's actually a very very nifty little feature that, if you have one of the use cases that we will talk about momentarily, actually is a very nice and portable and convenient solution, I think. So what are the use cases for HDF5 file images? Before I explain what HDF5 file images really are. So use cases for HDF5 file images would be, well, we all know that either for heavily utilized, but also a I/O subsystem that is maybe not that powerful, you would like to avoid that to a degree. So if you could do I/O in memory in double quotes, that would be a nice thing, and that would be one use case. So if you think the amount of I/O in terms of amount of data that you are doing could be done all in memory and then sort of closed out in bulk at the end, because that's where even slow I/O systems typically perform reasonably well if you present them with large requests. That's one use case. Another use case is, let's assume on the same system you have two processes, operating system processes that is, and you would like to share HDF data between them. And of course, you might say, well, that's pretty straightforward. I just use the file system and then have the two processes somehow communicate through a file system. But that's certainly true. You would have to add some kind of inter-process communication unless you use something like Swimmer. But generally speaking, in line with the first one, if that file system is heavily utilized, or you are really interested in the highest possible performance to a degree, again, this would be a use case where you would like to share HDF data between two processes without using an underlying file system, whether it's locally mounted or attached to the network. And then a third use case is, let's assume these two processes are not on the same host, on the same machine, but they are on two different machines, and you would like to somehow either incrementally or as a whole transmit, call them HDF5 data packets over a network. And typically, by network, I mean, think something like a TCP socket, or I mean, there are all kinds of different protocols, but for reference and for argument's sake, let's assume it's some kind of TCP socket. Okay, so these are our use cases. Now, what are HDF5 file images? And they are, in a way, what the name suggests. If you think of a file as a logical byte sequence, then an image of that byte sequence in memory is just an array. It's just a buffer. Okay. Of course, even in a file, it's a logical byte sequence, because we know that in file systems, I mean, files are not stored in file systems as long byte streams. They are stored typically as sequences of inodes that are interlinked and so forth. But logically, there's definitely in a file, in a traditional file system, each byte has an offset from the beginning of the file, and it's a logical byte sequence in that sense. And the counterpart of that in memory would be just a byte array or memory buffer. Now, the nice thing about this is that I/O operations such as read and write and so forth, they translate in a memory context just into memcopy operations, okay? And that makes them extremely fast. There is no disk I/O involved. A seek, since memory is random access, a seek operation is extremely fast because you can address directly any byte in that memory buffer. And this whole concept has existed for the longest time in HDF5 as the so-called core virtual file driver, where instead of when you create or open a file, you are not sort of accessing an inode or creating a file structure in storage in a file system, but rather you allocate bytes in memory that potentially can grow through reallocations and so forth as you are writing data to that logical HDF5 file. And now an HDF5 file image generalizes this concept where you say, well, now I can take that underlying buffer that represents that HDF5 file in memory, and I basically take that buffer plus a little bit of a management interface around that. The management interface around that that you need is basically for allocations, for reallocations, and so forth, pretty generic operations. And the typical way in C, at least, to deal with something like that is basically to have a structure of callbacks. So a memory buffer plus a structure of callbacks where you can either use sort of default C functions such as malloc and free and so forth. But if you want to implement your own memory management in this case, then you can use this management interface to do something special, to do something that might be more efficient for your use case. So that's what an HDF5 file image is. It's really just a memory buffer plus a management interface, which is basically a structure of callbacks. If you are interested in this and you want to get really deep into this, there is a very nice RC document, and I linked it here. It's just called HDF5 file image operations, that also contains many, I think 4 or 5 very specific examples. And I will sort of talk about one example in a moment. But this is really the definitive reference if you want to do anything with file image operations, considerations for efficiencies, how to avoid making copies of certain things, how to delegate or not delegate the ownership, because when you are dealing with memory buffers, especially in C or C++, it has to be clear who owns something, who has to free things, who has to reallocate things and so forth. But this is also all covered exhaustively in this document. So if we then have such a such a file image, we could, for example, to come back to our second use case, sharing HDF data between two processes on the same host, you could, through inter-process communication, you could have a shared memory segment where you share where the buffer is basically allocated in this shared memory segment. Of course, you would have to make sure that since the callbacks, the pointers, cannot be shared because both processes have different independent address spaces. So you would have to make sure that you wire those up correctly. But in that shared memory segment, that buffer pointer can be shared. And so that would be that use case. And the other use case would be, and this is what Vijay showed in his presentation. Let's assume we have two processes running in different machines connected over some kind of network, and let's assume we use sockets, some kind of TCP connections. And this is actually one of the examples in this document here on HDF5 file image operations. I think it's example 4.3 or something like that, that shows exactly that case. So what you would do is, in sort of my Pullman's sort of flow diagram here, on the left-hand side in that column, let's assume this is process A, this is, let's call it the producer process. And on the right-hand side, that's process B, that's, if you wish, the consumer process. Here's kind of the flow, what would happen. So in process A, you would pretty much create that file image. And in the document, there are many different ways how you can construct an HDF5 file image, either with the help of the core VFD, or if you have a file already, an HDF5 file already on disk, or even just a template file, you can pretty much bare bones read that from disk into a memory buffer and then hand it over to the file image constructor, so to speak. And then you would construct that file image and basically do to that file image whatever you need to do, write data, create groups, create that package that you would like to transmit. And then, of course, you would have some kind of open connection to the receiving process, and you would have to, unless there is sort of a predetermined size of increments in which you want to exchange things, you would first have to notify the other process of the size of that file image. So the receiving process, process B, would receive that size, and it would basically allocate a buffer of that size. And then once it's done that, process A would transmit that the contents, if you wish, of that file image, just a sequence of bytes, and then process B would receive that. And then at that point, depending on the use case, you could reuse that file image or close it and free the underlying buffer and so forth, and just do something else. And then over here on the side of process B, you would open that file image, and you know that the contents of this file image is just a byte sequence that represents a natively formatted HDF5 file. So you can use all the HDF5 file API calls to interact with that. And then, yeah, you sort of read the data, and then once you don't need it anymore, close it and pretty much free the underlying resources. And this is, of course, only the simplest case. It's sort of process A sending a packet to process B. But this, of course, could happen in a more coupled scenario where either process B sends something back to process A, or whether you have certain patterns like process A is just sort of pushing data to process B, so there's really an event loop on process A, and then process B. There is some additional protocol on top of that. So if you think about, you can, the transmission here from A to B, yes, this could be bare bones sockets, but you could also use 0 and Q or something like that. And then, of course, you might say, well, if I use 0 and Q, what do I need HDF5 for? I could just send all the bytes and all that stuff through 0 and Q. Is there really a point in using HDF5? Well, I would say yes, absolutely. If you're using 0 and Q and you just want to send some bytes over, there's absolutely nothing wrong. In fact, you wouldn't want to make it more complicated than necessary. The difference is that the moment these packets or this information that you want to send from process A to process B has some kind of structure, in other words, needs some kind of framing. So let's assume it's not really just the contents of an array where you have like a 5x6 array of floating point numbers and so forth. And then sure, you can just blast that over the wire, and then the other end has a priori knowledge of what's coming and parse it accordingly. The interesting use case comes if there is a degree of surprise potentially in the contents of this packet, where either you do not know a priori what the sender will actually send to the receiver. You can compensate to that for that to a degree by designing a protocol, designing framing that sort of in a way anticipates all the different possibilities and so forth. But that's then where you get in the trade-off curve, so to speak, into a region where why bother? Why would you invent your own protocol and your own parser and so forth? Then I think it's really worth looking at HDF5, because you know what you are getting is HDF5, and there is already an API for HDF5. The content that you are receiving, you can examine that. There could be a complex group structure in there. There could be attributes. So there could be multiple arrays. They could be decorated in certain ways. The HDF5 API easily supports all that. So you do not have to make any assumptions in the worst case on the receiving side about the content. You can all introspect and discover that at runtime. So I think the trade-off is really, if what's coming from the sender is fairly predictable and it doesn't require a special protocol or something like that, by all means, 0 and Q or similar approaches will cover you very well there. But the moment there is some degree of uncertainty there, and the structure of the data is such that it's more than just a flat array or something like that, and it's typically data of mixed types, where again you would have to come up with some kind of schema / protocol / sort of multiplexing, because you would basically serialize different channels potentially into the same transmission and so forth. That's where it gets complicated, and then it's much easier, in my opinion, to go with something like HDF5. Anyway, I think that's what I had for today, and there are other examples. It's really, if you think maybe that sounds interesting, it's not quite my use case, I encourage you to look up this document and look in section 4. There are other examples there, and really it depends on the use cases. Of course, there are other things to exchange HDF data between processes. We mentioned Swimmer, the single writer, multiple reader earlier. In the future, there will be VFD Swimmer, and there are certainly many other ways to do that, but that seems to be one that's very portable, very straightforward. And again, the benefit is that you don't have to design protocols, parsers, and so forth. It's all there. Anyway, maybe a few seconds if there are questions, we could talk about questions. Otherwise, time is up. I thank you for coming, and we'll be back next week. But maybe any questions, any quick comments? No? Okay.
I have a question, if I may.
Sure, you go ahead.
Hi, so thank you, Gerd. My question is unrelated to file images, and it's, well, I'm quite new to HDF5. I wanted to ask specifically about named types, if I'm naming the feature correctly. And my question is, what are the benefits of embedding a type inside inside an HDF5 file?
Okay, we can come back to this next time, but I will give you sort of the most direct answer. The benefit is that, of course, for simple types, other than documentation, it probably is not very valuable. So with a name type, you could create that name type in the file and then give it a name where you say, this represents a certain type of quantity whose unit is such and such, so documentation. But the benefit I think really shows is if you create data type definitions that are more complex and you just don't want to repeat them over and over again in code, for example, you could just create a template file if you wish, where you have another name for named data types is also committed data types. In a way, you have committed that type to the file, because if you have done that, you can actually, whenever you create a new data set or a new attribute of that element type, you can just open that type and pass that handle to the create operation for that data set or that attribute without having to write any additional code of first assembling that type, meaning, let's say it's a nested compound type of some sort where you first have to create the compound, then you have to add the fields and define the field. You don't have to do that. You can just take that, open that named data type and pass that handle straight to attribute and data set creation calls. Does that make sense?
Yes, thank you very much. That's indeed my use case, a composite data type that I was wondering whether I should put in the file or not.
Yeah, that is a typical use case. And the good thing is these committed data types, they are treated like they're also called objects. So you can copy them between files and so forth, like you can copy data sets and groups and things like that. And yeah, it's really just a convenience measure. And documentation, I think I like to talk about documentation because to make things easier to understand and accessible, I think documentation is a good thing. Okay.
Thank you very much.
Okay, good. Then thanks for the question. And yeah, we'll be here next week, and I look forward to seeing you again. Right?
Thank you, Gerd.
Good evening.
Thanks.